Hi there, I'm going to just walk us through some L'Hopital examples, and basically I'm going to just hit up the quotient problems, and they're going to be kind of our foundation for pretty much all L'Hopital problems. You're always going to bring it back to here, usually. So, let's just start off. I'm going to just set up a couple of examples. Let's start off here with a limit as x goes to, I don't know, infinity. Then what is x to the fourth over e to the x? Well, first thing we got to do is we got to determine if this is even valid, right? So, look at the numerator. The numerator says, as x goes to infinity, what does x to the fourth go to? Well, we know that goes to infinity. We look at the denominator. Now I'm just showing you the procedure, but a lot of the time you'll just look at it and go, well, e to the x, well, e to the infinity is infinity, so we know we have the indeterminate form, so we don't even need to write that out. And that's true. And you will get so comfortable that you won't feel like you need to write it out every single time. So what we do is we take the derivative of both the top and the bottom, and I'm just going to start writing in the solution to that because I don't want to bog us down with so much writing. Bog me down with it. So just remember, here, I'll write this one out just to be kind. d dx x to the fourth all over d dx e to the x. And there you go. So basically we're taking the derivative of both the top and the bottom, and you'll get the hang of this real quick. You'll actually start doing these rather quickly. Notice how the e to the x stays the same. And if you did, now that we have this solution, if you checked for indeterminate form again, you'd realize that you have it again. So what do? You do it again. So this is going to be the second time we do it. So keep going. And this will be 12x squared all over e to the x. Notice how what we're really waiting for is that numerator to not be infinity anymore. So we're going to do L'Hopital again. I know it seems like I'm kind of dragging it out, but I just wanted to show you really all the actual steps, and you're going to probably do a lot of these in your head and realize that, yeah, we really didn't need to show all and every step. Oh, well, this is what it would equal, but really the form is limit as x goes to infinity 24 over e to the x. Now, can we go any further? No, because the top is it's no longer an indeterminate form. If we plugged in infinity to this, this would equal 24 over infinity, which, if you solve that, is actually just 0. So this whole indeterminate actually tends to and goes to 0. So it's kind of an interesting thing that you can go through a lot of work and find that it all goes back to 0. So let's do another one. It's always good to get a bunch of these kind of problems. Limit as x goes to -1. Okay, so what does this mean? how about this problem? X squared minus 1 all over x plus 1. Well, let's check the numerator, right? Always got to check the numerator and the denominator. Well, that's going to equal 1 minus 1, which equals 0. Denominator, that'll equal negative 1 plus 1, that equals 0. You have the indeterminate form of 0 over 0. Let's use L'Hopital's rule. So now that we're doing that, we know that we have x going to negative 1, and we know we have this function, x squared minus 1 over x plus 1. Let's just take the derivative of both the top and the bottom, and this is x is going to, let me correct that, x is going to negative 1, okay. So, as x is going to negative 1, I'm going to take the derivative of both the top and the bottom, so we're going to have 2x all over just 1, right? And that's taking the derivative of both the top and the bottom. Well, if we plug in negative 1 to this, then you start to see that you have negative 2 over 1, which is negative 2. And that's our solution. It starts to get pretty quick once you understand the whole procedure, and sometimes eventually you're going to get to the point where you don't want to write it all out. But the procedure, once you understand it and you feel comfortable, you'll actually just burn right through all these. Let's just do ln x over x. This is a really simple one, but as x goes to infinity, so you look at numerator, right? Well, ln infinity is infinity. What about the denominator? Well, x, that's going to infinity, so it's just infinity over infinity. Which, that just says, use L'Hopital's rule. So what do? Well, we got to sit back and look at it for a second. You go x going to infinity. You have ln x over x. Okay. Well, we're going to do L'Hopital's rule, take the derivative of both the top and the bottom. The derivative of the top is just 1 over x. The derivative of the bottom is just 1. So, your resulting, as x goes to infinity, the whole thing is just going to equal 1 over x. Well, what does that equal? That's no longer in indeterminate form. That will turn into 1 over infinity, which is going to equal 0. Divided by infinity. And I mean, this stuff, you see that there's very little steps to it, and actually the way the guy determined that this was possible is a little bit more complicated than actually doing it. But, you know, we don't... you don't always need to know all the details on how something came about, more so how you can utilize it in math. And what we're going to do is we're going to follow up on maybe some different forms that you might see. You might see indeterminate products, you might see indeterminate differences, and also there's going to be a little power section at the end as well. So I'll see you guys in the following videos.